I again forgot about the whole thing. I forgot about the intro segment. Anyway, it doesn't matter. Hello everyone, welcome to another live stream, and today we'll be working on the contraption. Yes, it's the contraption, everyone. It's the contraption. It's gonna be a bit tricky to explain what it does, but you know what? I'm gonna actually start this live stream by getting myself something to drink. It seems only right. It seems only right that we start that way. Can I hit this fucking wheel? Anyway, hi Greg, hi Remco, hi Generic Person, how you all doing? How are you all doing? Remco, we haven't talked in such a long time. Anyhow, this right here is the current state of my desk. I know that there is a lot going on. But that's because, well, I've been working on a lot, so you know. More stuff for us to enjoy. And I think we should actually start this live stream by me explaining what this chip right here actually does. And we could even record it as a video. Make it research. The show we do physics to piss of the chemist. Yeah. We do physics to piss off the chemist, we do chemistry to piss off the physicists. We do computer science to piss off the mathematicians, we do mathematics to piss off the computer scientists. We do it all. I know, right? We should collab soon again. Yeah, we really should. Anyhow, when. We're gonna start this live stream by recording a brief video for this channel, just as an explainer for what this chip does. And that's simply because, let's see if the LEDs will light up. Did they blink? Did they blink or did I just... I'm pretty certain they blinked. Or maybe I'm losing my mind, I don't know. It's a little... No, Remco doesn't have Alex Horn vibes. No, that's way off. But I need like a lab assistant, you know? I suppose, no, Katsi doesn't quite have Alex Horn vibes either. Like, Alex Horn would have to be a lab assistant who... But I need to find someone like that, you know? We need that kind of lab assistant. I remember like Alex Horn, I know, but I really need, but you agree with me, right? You agree that I need to find myself an Alex Horn. Okay. So basically, first things first, this right here is the code I have written. It's very short because there isn't much there. I completely just guessed how this is supposed to work. Basically what this code does is there are 3 pins on the multiplexer that we care about, the latch pin, clock pin, date pin. And in the date sheet it did say that clock changes from low to high, if I remember correctly. So I just do clock pin low, then the data, then high. I do 100 microseconds in between each one, just to, because otherwise it was a bit I can't be honest because I'm tall. Yeah, Greg is massive, famously so. What do I have to do with Alex Horn? No, wrong Greg. Hi, the cutscene. Unfortunately, Cutsy, you don't have that Alex Horn vibe, you know. No, unfortunately, no. Wait, hold on, I just got distracted instantly. Right. So let's get it started. And by get it started, I mean let's run it and see if it works. So it's gonna be CD surgery, and then it's going to be multi. Ah, beautiful. Binary counter. Splendid. Okay. Okay, hold on. Let's record really quickly a video. Because I just feel like this could require a bit more of an explanation. Alright, I'm gonna record this because it is something that I mention a lot and I've never actually bothered to explain it, and it's really important, really useful. Basically, right here we have a Raspberry Pi 5. This Raspberry Pi 5 has a limited amount of pins. It's either 30 or 40 or 20, something like that. The exact numbers doesn't matter. The point is it's limited. Now this Raspberry Pi has a lot of computational power, but only few pins. And there might come a time when we want a lot of pins for that computational power. So for example, right here I'll be working on a board which will have an SPI connection, irrelevant, SPI is not important right now, but each one of these will have an independent chip select, which will be the on or off. And spending a new pin if every single time we want to select a different chip is a huge waste, because eventually if we had like, I don't know, 10 devices or 20 devices, we would already be pushing it, and we eventually could end up in a scenario where we're not utilizing our Raspberry Pi 5 fully, but we're still wasting pins. So, what shall we do in that case? Well, that is where multiplexer comes to play. So this little chip right here, or these chips right here, because I've bought a whole bunch of them. And actually, you know what, let me draw it out. Let me just draw it real quick. Paint is what I'll need. This requires a lot of it's a good sound new genre of baking classes. Bake it with Make It. Today on the menu, Raspberry Pi. Alright. Okay, so basically, here are all of the pins of a Raspberry Pi. There is 40 of them. And when it comes to data, we do have actually relatively limited options. That's because we really don't want to use these pins, because they are all for power. So these pins kind of go out the window. Ground the same way, right? We don't really want to use the ground. Like so. There we go, there we go, there we go. And there we go. Okay. Then we don't want to use the blue ones either, because the blue ones are actually, or the teal ones, they are actually, you can use them for I2S, which means audio, so we don't really want to use them. Because if we use them, then we won't be able to play any audio. Also, we don't want to use this power pin. We also don't want to use the pinkish ones, because the pinkish ones are for SPI, which means that if we use them up for something different than SPI, then we won't have access to SPI. This is quite important. At the same time, we don't want to use the SPI, the I2C pins. The reason why is because if we use them up for something trivial, then we won't be able to use I2C. We don't want to use UART pins for the same reason. UART, once again, is very important. And basically, so on we go. And you can realize that at the end, even though normally we'd have like 40 pins, at the end we're left with a handful. Like a handful of GPIO pins, which can be the on or off. So we're left in this scenario. We have 1, 2, 3, 4, 5, 6, 7. Well, these two I guess also don't belong to 8, 9, 10, 11, 12. We have around 12 pins left. But let's say that we want to have a whole bunch of LEDs connected to a Raspberry Pi. Something like 16 of them. Each LED can be either on or off, which means that theoretically for every single one of these LEDs, if we wanted to actually connect them, if we wanted to actually make them work, we would need the whole separate GPIO connection, right? GPIO stands for General Purpose Input Output. Well, not quite, because that's where our multiplexer comes in. The way a multiplexer works is very basically, we just plug into it a limited amount of GPIO pins, something like 3, and it outputs a whole bunch of pins that we can control. That is the job of a multiplexer. Which means that if you want a lot of outputs, but only have a few, then the multiplexer could multiply them out for you. It could give you more outputs. And that is basically the reasoning behind... Oops, I grabbed the wrong bag. Behind these chips right here. You connect effectively just 3 lines, which is the first clock, second clock, and the data. And out of it, you can get 8 different GPIOs, which is great. So right here, I have 3 LEDs connected. Only 3 because I just honestly couldn't be bothered to add more of them. And if I run the code, I've set it up, we are controlling all of them. But the important thing here is that I can control up to 8 different LEDs And I can do it using only 3 data lines, which is why it's so efficient. Which is why I mentioned multiplexers so much. Normally I use Raspberry Pi Picos as more complicated multiplexers, which I will get into in a main channel video in the future, but that will be way later down the line, so that's a brief explanation. There we go, finish recording. And now from now on, if anyone ever asks me about multiplexers and why I keep mentioning them, what they are, then I can just link them to this video. Anyway, that was it. Multiplexers work. What we'll need to do today is we'll need to set up this right here with that multiplexer in a way so that it will work, which is difficult. That's a difficult order. Crazy how you can sand with sand to make, or make with make, but not pie with pie. I've never thought about sanding sand with sand, honestly, but I can see the appeal. Hey, why not? Okay, first things first, the planning stage. Oh, that is sour. Alright, what will we need for SPI? Because we have connectors, and those connectors have 1, 2, 3, 4, 5, 6, 7, 8 pins. So I have 8 different pins. Let me actually also play some music for myself, because I need something manic again. And my animation rendered. Funny enough, in the background I'm actually rendering how SPI works. Oh, and there are the hours. The hours are not important right now. This is 4:30. And this will be a 7. Okay, brilliant. Why is everyone so quiet all of a sudden? Jeez. Speak up, don't be shy. Did I scare you all off with SPI talk and multiplex talk? I promise it's not that complicated. 1, 2, 3, 4, 5, 6, 7, 8. The connections we need are MOSI, MISO, clock, chip select, which would be right here. Then, do we need a reset? I don't think we need a reset pin actually. Depending how the reset pin works. Do we have a reset pin on the screen? Yeah. How will do reset pin work? Because the important thing is, do they need to be always on or always off? And then RC522 just as a datasheet check. Last Minute Genius, that's a brilliant website. Absolutely. They make absolutely phenomenal graphics. Resets what I'm interested in. Well, that's curious. When this will put low, the signal changes from to high, merger resets becomes active again. Can it just be disconnected? Please. Can I just not have it connected to anything? Because not gonna lie, that would be quite helpful. TX! You are shitting me! That is actually TX! I could have sworn that doesn't work. No! It is TX! Oh, that is phenomenal. RST SPI. Working specifically for RST pins. Yeah. Is it standardized? Because we would very much like something that's more standardized. Because I don't want to connect too many pins. In this case, what we also need is we need 3 volts. Actually, we could do 3.3, and then we could also do 5 volts. Yeah, I guess we'll need to. Yeah. RST. The reason why this is separate is because this will come from a multiplexer. Mosi, Miso, CLK, 3v3, 5 volts, RST. We have one pin free. We can use it for something, I suppose. Like status callback, maybe? Let me check the monitor, the screen I have. It is ILI 9341. Pin description, yes. Oh, goodness gracious me. How many pins do you add here? Hold on. Are those like internal pins? No, are these the pins of the screen? Oh, I have a module. Absolutely, I don't care about the pins of the screen. I don't have access to them, nor do I want to have access to them. Okay. So unfortunately this won't really be of much use. Exactly. Oh my goodness. What a helpful graphic. I lost it right away. I don't think I can even zoom in on it. Helpful graphic, alright. Yeah, that won't really help us. This is not a sample code, I guess. Out of curiosity, do you have the same pins I do? Not quite. Okay. I could specify wave share. Wave share wiki, let me see. Okay. So this is that's 18 by 8 bytes of RAM. Each pixel in depth. Yeah, for 8 modes. Okay. So we have 4 control cables. Do we even have them? We don't appear to have them. I mean, okay, we have DC. Hi, Detenze. How you doing? Okay, but this is just... Yeah, this is the same date sheet, isn't it? Alright, gotcha. How's work going? It's not bad. We're actually... Right now I'm doing just a bit of research before working on the project. It's the last bit of research, shouldn't be much. How the description. Okay, we don't have access to any of these pins. We can skip them. Taking short break after midnight coding. Oh, what were we coding? Yes. Data analysis is not interesting now. Well, I don't know, it could still be interesting. see. We have DIN and CLK. DIN CLK chip select. That's all from. Oh, we don't have Dowd. We have Mossy. We don't have Miso. That's curious. I know I'm not showing you much, but I'm just looking at this. Right here at the back, we have pins, and I'm just looking at them. That's all. Reset the controller, low active. Okay. I like how we have both reset and chip select, because they're needed apparently. That's why I use a multiplexer. We could actually have another multiplexer here for the reset. It just got me thinking. You could then reset them independently. Would 2 multiplexers be too much? Oh, let me actually look at the pins again. We're using these 3. We're using them, which means we need to use 4, 24, 25, and 5? Or we could use 5, 6, 16, I suppose. 5, 6, 20. Or we could write to both of them independently. We could use a clock. Oh, that'd be clever. In that case, we could just add 1 more pin. So 24th. Oh, that is quite clever. Oh, I like that. In that case, reset. In that case, both of these would come from multiplexers. Oh, that is so clever. Ground! Jeez, I was forgetting about the ground. Never mind, we have... That's as many pins as we can have. Okay. G and D. Alright, gotcha. So we reached the limit of what we can have anyway. Because that's 8. We'll need 2 multiplexers. This will be actually quite really tricky. Not gonna lie. Thankfully, we do have this, and I have it working, which means I can just put it to the side. I cannot put it to the side, I don't have any space. I can put it to the front and leave it there, just so that we have a working reference for when we inevitably mess things up. Alright, so now let's work on... Really quickly, let's set up the connection of our multiplexer, which I will need 2 of. I'm so glad I bought them. I really should just order more. They're brilliant. And by brilliant, I mean they work, which you would be surprised how often that is not the case. Pyrex, SN74, HC595N. There we go. Alright. Right here we have the pins. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Voltage. I'm pretty certain it's 5-volt power, isn't it? No, egg on my face, we can use 3v3, which is what we're gonna use, because I prefer 3v3 for logic. Wait, actually, if we can use 3v3, then if you don't mind, I would like to test it, because I'm pretty certain we did it on 5 volts in our Raspberry Pi example. I can run it the exact same way, all I need to do is just switch it from a 3 volt... Oh, it's on 5 volt power right now, which, if I'm not mistaken, on the other side should be 3 volt, right? Yeah. Okay, so it's on 5 volt power. All we need to switch it to 3 volts is move this pin over. Okay. And then if it still works as a binary counter, well, it looks like it's working. Yep. It certainly looks like it's working. Brilliant. Because this means that we can do it with 3 volts, which is what I would rather do. Now what we need to do is the annoying bit. Or the difficult bits. We need to connect all of these. We need to solder them all together in a way so that they all have sufficient amount of space, but at the same time are packed as tightly as possible. And we need to make sure that all of the connections are right and correct, because if we mess something up, that would just be a massive waste. I am going to assume a fair bit of things here. All of the assumptions should be correct, but if they are not correct, then I will be in trouble. Okay, there we go. Alright then. It's not gonna be fun. I'm really excited for when the video on this project comes out. I can say much better than this. Tense, the nice thing about this project is that this is going to be a whole series. And the first episode, which is just this right here, that should be ready either tomorrow or in 2 days. Because the reason why I'm dividing it into series is because on their own, each step of the process is really easy to explain. It's the totality of it, the fact that there are just so many things, that's what makes it difficult. Which is why I'm just going to divide into a series and then, well, explain it step by step. I'm having fun, I'm not gonna lie. With this project, I am genuinely having a lot of fun. Where is the sponge? I need the sponge. Without the sponge, the soldering iron is gonna struggle. Also, it's warmer at 200. We need way more. We need 300 at least. Right. I think I've lost the sponge. Oh, that sucks. I could have sworn I had it in my hands like seconds ago. But yeah, the thing, I don't know where I'm gonna finish up with this project. My plan so far, as I mentioned in the past, is I'm just gonna keep going until I won't be able to continue anymore. Which I imagine it will take a fair bit. Yeah, no, there's just no sponge. I'm losing my mind. I'm just losing my mind. Okay. One more thing, which I was actually supposed to do, but I didn't, which is because I got distracted. Right here we have VCC. Right here we have ground. Those are the things. That's the wrong date sheet. This is the correct one. Then what? Then we have as the voltage. Voltage also goes to the second most bottom pin, which is SR clear. These come together. It's a nice way to achieve permanent logic. Just connect it to voltage to not waste any GPIO pins. If you know you're not going to be using it. Ground goes there, but then we have 3 more pins as are the data pins. Alright, so blue is the third from the top. We have the serial R clock, SR clock. That's why you can go on over here. Keep going till you can't. Exactly. Okay. SR clock, SR clock, and serial. Those are the 3. Is that really it? Oh my goodness. I was expecting it to be much worse. Alright, and in that case, the data pins, unfortunately, are ever slightly annoying because our data pins are right here, 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 here. 1, 2, 3, 4. All of these. I think we're gonna leave this one for a LED, and we're just gonna use these. Yeah, I just feel smarter. All right. Oh, in this case, this is gonna be good. This is gonna be fun. This is gonna be quite something. Which is why I need a sponge. It's important. It's gonna be a difficult solder job. And I'm not gonna be doing it with oxidized soldering iron, because I'm not an idiot. Yeah, no. The nice thing is, you know, I don't open my windows much when I do anything, because it's cold outside. And kind of loud. Well, not this late at night, so normally because it's cold. But if a soldering iron on, it's nice, keeps a nice balance, you know. No, I'm just losing my mind. Screw it. We'll need to use paper. Just what else? What else can we? Oh, I found the sponge. Never mind. Okay, we can use the sponge. Sponge is very important because due to heat, your soldering iron oxidizes really quickly. And when it oxidizes, it can't really conduct temperature quite as well. I'm sure before it's even her, I'm confident in single word. This word is absurd. Life has been different. It's years, relentless introvert. I can't help but feel loudly. I slide the phone. Okay. There we go. I have my cheat sheets on the other screen to make sure I don't mess anything up, but I still think I am gonna mess a whole bunch of things up. So first things first, we need mosi miso. That will be on the edge. Soft ground. You know what? I am gonna actually play myself some Jamie Page in the background, because that music is magical. Whenever I play Jamie Page, everything I do works out well for me. All right. I'm stalling. Yeah, I'm stalling because if I mess something up, it's gonna be really annoying to fix. But fine. No, actually, first small the camera, because first we need to cut the wires. We need to completely remove the jackets. That's because, well, it's gonna go for length. Okay. There to hear your voice. That's really hard in a choice, but when I live, I spend it between I wanna meet you in the middle. Oh, ho, ho, ho. Yep, okay. Alright, let's pop the temperature up a bit. 300 is not good enough. What time is it in Poland right now? I don't know. Hold on, let me check. It's apparently around 11 p.m., 10 p.m. Beautiful. Okay, that was absolutely beautiful. Oh, it's a lot of smoke. Yeah, so now already we have two of them connected. They're not connected properly, obviously. They're like mechanically, you get what I mean. I don't know, I feel the need to explain everything I do. Hi, the caper. Again. Where have you gone? Unbelievable. As the science master... No, that doesn't work, does it? As a make master... that one works. I'm sorely disappointed in you. How dare you leave? So that was impeccable. Thank you. Yeah, no, I'm professional. Oh, this is... I don't mean to say that I'm really good at what I do, but I truly am. Now we're gonna solve the opposite side as well. Because it's really important that it stays connected. I think I love you just a little. Alright, there we go. We have them connected. This is what it will look like. It will have like a whole bunch of connections. All of them will be for SPI. Now, let me look at my cheat sheet again. We'll have Mosi, Miso, CLK, 3v3, 5v5 ground. Actually, we should do 5v5 out first, then the ground. So right here, well, it doesn't actually matter now I think about it. Well, it will matter for me. So now what we need to do is, very importantly, we need to add in the header pins. But those header pins have to be exactly on the edge. Don't have much space. Can't lose it. I just blinked and dozed off. Fine, understandable. Hey, listen, I get that what I'm doing may not exactly be interesting, alright? But still, I mean, have some decorum. I really hope it's soldered properly and not a mess. Yeah, it's not bad. Okay. Now we can zoom out. And that's because our next task will be this. Should I get myself a cheat sheet of all the acronyms mean? I'll be brutally honest with you, Tenza. It pisses me off as well. I've complained about it a lot already. About how many acronyms there are in computer science. SPI, if I'm not mistaken, is the serial peripheral interface. Basically, you can think of it like USB. It's kind of like USB. Except it could be a bit faster. Actually, I don't know if it's faster. But it's used for modules. It's more of waking up, still wanting to enjoy peak on if it means napping with running resistance subconsciously. Okay, but in that case, to go to sleep. I don't want to keep you awake. I want to go to sleep, go to sleep. When you wake up tomorrow, there might be a video. How about that, huh? Come on. We need to strip the entire jacket because it has to be connected lengthwise, which is quite a fair bit annoying. off you go. We don't have patience for that sort of thing. We will not tolerate that kind of behavior. Get this yellow off of you. Time change rescrews. Oh yeah, the night was longer, wasn't it? Jeez. It was a longer night, wasn't it? As when I was off doing my hypothetical. Ah, how am I supposed to connect this? This is awful. Okay, connecting this will be a bit of a pain. Because we effectively need to, well, we need to flatten it ideally first. And flattening wires always gets so annoying because they really don't want to flatten themselves. Fortunately, I'm very flattering, so. Funny. Comical. I know, hilarious. You can, so I know, I'm funny. Okay. I think we'll just need to lay it down link, but later on, in those middle connections. Yeah, over there it's gonna be tricky. It's gonna be really tricky. We need to like lay it on top. We could try soldering it from the middle, because the middle ones would be the most difficult to do. We could do it bottom up. It's risky. Risky because one wrong move and well, I'm doomed. It's a good run. It's a great making of the Alright, bye Caper, bye, have a good one. Good luck on your future endeavors. Okay. Should be able to just solder this like so. Yeah, this will be challenging. I already almost messed up. This will be one of the most difficult solder jobs I've absolutely ever had. Let's see. Okay, let's test it out with our multimeter. Because in order to test it out, all we effectively need to do is set these so that if there is a connection, they will detect it. And now, okay, so far that's correct. Do you wear goggles or something when soldering? No, I do not. I don't wear anything. No gloves, no goggles. I can't afford it, to be completely honest with you. Can't really afford any safety equipment. I could make like a cable straightener, I suppose. That could maybe help. Well, most definitely would help. Okay. That'll be fun. Oh, this is bloody awful. Okay. Can I maybe please and not to be holding it? No, I can't. I could, I suppose, maybe put it right here, then bend it. And this potentially could help me. Uh, what is engineering as a project? Is the project or separate? It is also in this, yes. I will. The operating system, I don't want to call it an operating system because not that kind of operating system, but the system that will kind of run all of these devices will be called Fixit. And yeah, I'm not above adding some AIs in there for funsies. Some, voice to text, some text to commands. Oh fuck, there's a lot of smoke in my eyes. Ah, yeah, those goggles, good idea. I'm really looking forward to watch the video tomorrow. It could be tomorrow, it could be also in 2 days, because I don't want to overpromise either. I still have a lot of work to finish that video. It's just that I won't be reworking anything else today, so there's a solid chance that it could be. I hope it'll be tomorrow. That I could fall right into. Good. This is good. This is good. Good. Okay. We have connection between the second pins, and it is not connected to any other pin. A good start. Certainly a good start. Okay. That should mean 6. Wait, less than 6. 4 to go. Yeah, because the other ones will need to connect to the. Actually, we could use just a single multiplexer. Oh, that's true. We would only be able to plug in 4 SPI devices then. I'm fine with that, I think. Yeah. I like the idea of using just a single multiplexer, maybe. I would also like the idea of using 2, though. If I use a single one, then I won't have a spare pin for the LED. But if I use 2, then I might be wasting a multiplex for no reason. Oh well, let's go crazy. We're gonna do it with 1 multiplexer. Come on. Okay, that should be it. Only right here we need to bridge the two. Okay. Genius, where I am, where I live, and I'll go see you. Good night. Good night, Tenze. Good night. Have a good one. Okay. Oh, that's brilliant. Wow. So far we are 3 for 3. I haven't messed anything up yet. Fourth time the charm, alright? Mostly miso clock, that's what we have so far. Then we'd like 3v3, 5 and ground. Okay. Okay. Nothing like just a silent stream of naked soldering something you can't even see. Great content creator. Okay. Jeez. That's the fourth one. Which would mean... Okay. Once again, wow. 4 down. 2 left to go. That's the 3 volt and the ground. Yeah. second. Shut up! Daddy's busy. Okay. Once again, this is the 5th one, right? Which means after this one, there's only one left. Thank goodness. Genuinely one of the more terrifying solders I've ever done. Because everything is exposed and there are so many connections to make. And they're all data connections. Or almost all of them. Which means that if I mess up even slightly, I will not have a good time. Okay. Shut up! You know what, I'm gonna switch the players actually. I'm gonna do some maddening science. And first actually I'm gonna grab the bite tweet. All this pressure just makes me hungry. Alright. Now. We have 2 connections left on this line. Then there's the next line. And then that should be all of the long connections done. Which means the next part, which will be easier but significantly more work. That's because the next set of connections will be one by one. Which means we pick them specifically. Which is actually quite convenient. Yes, another bite. I'm hungry, right? Because pressure makes me hungry. Hungry. No, actually, no, both. Fuck it. Absolutely pissed. Okay, this time I went down seriously. Alright. Beautiful. Absolutely beautiful. Now what do we need? There's just the one last connection. And then we're done. Oh, my sweet. I'm trying to measure the space between your molar and your jaw. This can't pair. Don't gasp for fear. Know it. It doesn't hurt. Only helps me measure how much skin you have on the topmost layer of fat. But I won't make that incision nice and numb. Oh, when laughing, that can be so much fun. Please don't my decisions. This will be ooh, this will be ah, this will be absolutely wee. This will be nice, this will be neat and bring you closer to me. So don't you fret. I'm not gonna hurt you. Yet I just feel the need to be getting a little of you, a lot of bloodletting. I know the sensation you're probably dreading, but cutting you up will be so refreshing for me. Yep, refreshing for me. Yeah. No, don't you cry, and don't call Nelia. She's my alibi. Oh, let me check your toes. Honestly. Red is such a lovely color on you, but you won't be needing to go, and you got no needs. Machines or pinky fingers or arteries, so hold still while I remove them. Okay, this looks proper. That's another view. This will be ooh, this will be this will be camera, die! Why didn't you tell me? Don't stir the mood, so don't you fret. I'm not gonna hurt you. Yet I just feel the need to be getting a little of you, a lot of bloodletting. I know the sensation you're probably dreading, but cutting you up will be so refreshing for me. Once upon the time, that's where the plot begins, and right after the end, that's how the blood thins the end. I got no angel to keep me in line, so I'm taking your narrative and I'm making it mine. Oh shit, I've cut it a bit too much. Whoops. Be ooh. One last. So refreshing. Yeah. Refreshing for me. Brilliant. Now what? Now the other two will be reset and chip select. Which will be a tad bit more tricky. Because that's where you, cheeky little bugger, you come and play. Oh, look at it. It's lovely. The day they found me, I haven't yet been playing. Inside my workshop. I could put it a bit closer, I suppose, but then we might not have enough space. And that would be tricky. Okay, let me just check my cheat sheet again. It's VCC on the top, VCC from the bottom. So VCC right here. Does that work for us? Ground on the other side. No, ground would be easier to get. And kill. I can't be beat. I won't hurt. Cheat. Alright. I think from the top down we should do the voltage and ground and data. Yeah, and from the other side you can do the other things. Simple as it could be. So right here is where we'll have the chip. Soon appear, quickly once revered. This must be what love would have felt like. Love would have felt like. Such dedication. Away. Okay, so the pin I just soldered is... No, absolutely irrelevant. It's one of the only 2 pins on this entire device we don't actually need. Good, brilliant. That's splendid. Okay, the pins we actually need are... Right here, this one, this outer one. That's the power pin. Which means we need to solder it to 3 volts, is what we just used for power. In this case, we can keep it shielded because well, that should be fine. 18 location maintenance, man. Actually, let me copper wicks some of the solder away because it's a bit much and it bothers me. Who knows? I only want to have fun, but now they're telling me my dad but they make Japan and produce. See my blood under stickers. Oh, now you're sticking out a bit. Jeez, I'm really missing like 7 more hunts. Okay. Yeah, the first pin is actually. Oh wait, no, it's the inner one. Well, I almost fucked that up. Haha. It's the inner pin right here. This is the voltage. Thank goodness I double checked. Friday, read my make. Right, everybody's gonna die. You to know truth. The truth about me and the truth about you, 'cause you're a brand new species. Big space Nazi. Robert Stark. Call me back. I've tried to call you every day. I'm rehearsing what to say when the truth comes out.
Sure.
Oh, hi, the flame. How you doing?
Hello.
Can't spook me like
I'm good.
God, you can't scare me like
Yeah.
that. Jeez, I was vibing, and you scared me. I don't have health insurance. If I go with a heart attack, I'm done. Right, this one, cut it. Gotcha.
I don't think I have health insurance either.
You don't? Aren't you a student?
I mean, we just have free healthcare.
Oh, you.
Don't need to insure it when it's free.
Unbelievable.
Yeah.
Well, how are you doing? How are things going for you?
Things are going really well. I left the lab at 7:40 today.
Oh my goodness.
Which is quite late. That's because things were going well. Like my curiosity was piqued.
That's good, because usually when you leave lab at 7:40, things are either going really well or really badly. I'm glad they're going really well then.
Nothing's gone really badly yet. I mean, have I like even told you what I've been doing?
No, you haven't, because you. I don't know if you remember.
I mean, I can tell you about what I've been doing without explaining NMR.
Well, I mean, you can try, I suppose.
Well, like, I mean, okay, basically, the last month, I've just been getting trained on NMR by doing solid-state NMR on other people's materials. So this is like things that people have made, like people are researching, and they give it to my supervisor. They're like, "Oh, can you do NMR on this?" And then he gives it to me. He's like, "You train on this, do the NMR," and so then I've been like basically just giving these other people the information they want for their research.
Oh, that's really neat. You're the NMR guy now.
Yeah. So now today I started working.
Wait, that means
on a very small portion of a paper.
Wait, that means you are just like doing proper NMR by yourself by now.
Yeah.
Wait,
I mean, it's quite easy when you've done a certain experiment. You can do it again. Like it's quite easy to do it again. It's just when something's different.
And is it the same with all the chemicals? Is there nothing different about them? Like no unique.
Oh, I mean, there's. Okay, most of the NMR I've been doing. I mean, you know there are NMR active nuclei, right?
Let's say no.
Do you know this? Okay.
I know nothing about that. How many times I do?
Okay. Specific nuclei. So okay, you know that different nuclei have different spins, right?
Yes.
Okay, and some nuclei have spins such that you can't see them in NMR, and some of them have spins such that you can see them in NMR.
Why?
Well, because if a nucleus has spin 0, then it's not gonna.
Oh, it's not gonna
interact with a magnetic field.
But wait, plural spins.
Yeah, they can have more than half.
Shut up. Don't mind that. It's just being a bit of an idiot. There we go.
Just the beeps.
Yeah, the beeps still keep me sane. Okay, that's good.
So I've been doing mostly carbon, fluorine, nitrogen, proton, NMR. Did I do any nitrogen actually? I don't think I've done nitrogen yet. I've been doing mostly proton, carbon, and fluorine NMR. When we do carbon NMR, the thing is the most common isotope of carbon, which is carbon-12.
Yep.
The most common one is 99% abundant. So 99% of the carbons you find are carbon-12, and carbon-12 is not NMR active. So when you do NMR on carbon, you are looking at carbon-13, which is only 1% of the carbons. So you get very low signal.
Still 1% is not bad. As bad as it could be.
It's not bad, but it means that okay, if you think about it, an experiment takes 100 times longer than it would if because it takes 100 times longer to get the same amount of signal.
I suppose that's a fair point.
So this is why I've left a carbon spectrum running overnight tonight. So the proton ones are done in 5 seconds, and the carbon one is done in 12 hours.
Oh, is that why?
There's a slight discrepancy. Yes.
Oh, okay.
I mean, there's more to it than that, but like that's the obvious one. We'll get into relaxation in T1 and T2.
I don't think we'll ever get to it. No, I mean, I'm just... You've kept me just wondering for such a long time now.
Well, how long are we waiting for this art?
It's not. I haven't even ordered the art yet because
Order it.
You say by the time it's done, we may be there. Okay.
Yeah, we start streams when you've got the art.
Okay, I'm messaging on Martin right now.
Okay. You're gonna show up with it tomorrow. You're gonna be like, stream now.
I'm gonna pay extra.
So the past month I've been just doing NMR on other people's samples, but if you remember, my PhD was meant to be discovering new materials. So this week, or last week, I did my first actual synthesis, mechanosynthesis.
Mm-hmm.
Do you remember what mechanosynthesis actually is?
Smashing balls together until you get what you want?
Yes.
Yeah.
So I take my... Wait, actually, I have a picture. One sec.
Oh, that's very orange.
So okay, so I start with the orange and white and yellow powders, and then I
I can tell you're a chemist. You start
and then I stick them in the thing with the ball, and it shakes them for 30 minutes, and I end up with this. It's loading. I end up with that.
Oh, that is very mechanical. Wait.
Which is not as pretty.
Wait, how fine is that? Oh, because it's mechanosynthesis, right? That is so confusing in my head.
Yeah, it's all smashed up, so it gives you a powder.
Yeah, but that's so confusing in my
to put
brain.
it into like put it into context, the top image, that whole the like diameter of that whole thing is like 2 centimeters. So it's not that big.
Oh, okay. But still, that messes with my head because it's mechanosynthesis, right? Like, in my head like wants to think that it's mixing, but it's not mixing, it's synthesis. It actually changes. That's confusing.
Yeah, it's actual reaction. You're not just mixing stuff.
Yeah, I mean, yeah, I know. It's just that, like, my brain constantly goes to mixing when it's mechanochemists. You just need... I cannot with you.
There's a video of the reaction happening.
The shatter is incredible.
Yeah, I think it shakes them at 30 hertz.
Oh my god!
The fastest this goes is 30 hertz.
It looks like your phone is drunk when recording this. That's so funny.
Peak mechanochemistry.
Peak mechanochemistry, indeed.
I can tell you something actually. My supervisor got kind of famous this week.
Oh, why? What happened?
Did I tell you did I mention anything about Teflon before?
Well, you did, but I don't know it was relating to this.
Did I mention Teflon and sodium?
I don't think so, although I could be wrong.
Okay. I'm only telling you this now because there's only 2 people watching the stream, so don't tell many other people.
Yeah, it's gonna be lost. Yeah.
But if you Google Teflon recycling, you will see some news articles saying scientists discovered
Oh yeah,
something.
With hundreds.
Scientists includes my supervisor here, and his contribution was basically some people basically they took Teflon and they took sodium and they put them in the ball mill, and they realized that the sodium yoinks off the fluorines, which is spectacular because Teflon is well known for having fluorines that are never letting go. So all they did, they stuck sodium in it with it in the ball mill, and it just takes the fluorines out, and you can react the fluorines with something else. And my supervisor, he did the NMR for basically telling them what's happened in the reaction. So saying oh yeah, the Teflon's reacted, the fluorine's gone here, and this, which is very cool.
That's really. I genuinely, when I look it up, it genuinely just show up. That's incredible. Wow. Damn.
Yeah, it kind of blew up on the news for some reason. But it's very cool. And he was when I was visiting the lab over the summer, on my first visit in I don't know, in June or July, he was showing me some spectra. He was like, look at this, someone's discovered this thing with Teflon and sodium. Look at this spectrum. And it was on the day that he'd measured and now it's published.
It feels wild to just be in such direct contact with cutting edge science, because normally you just hear about this sort of thing. It's so weird to just say my professor. It's wild.
It's very cool.
He
was recording a video of the mechanochemistry the other day, and I was I messaged him being oh, can I help with anything? And he was like, oh yeah, I forgot you have ample video editing experience. And I'm not really.
I mean, you know a guy, so you know.
I know a guy.
Hey, I'm not above helping that sort of thing. Listen, I told you, I'm more than willing to help with this sort of thing. I would love to help. So you never
it would be very cool. I mean, he was just recording a video of the actual the ball milling, which is not very exciting. I'm gonna be honest. You put it in, you press the button, and it shakes. Why did I just get an email? Okay. Anyway, yeah. So I'd started my first synthesis a few days ago, and this is also something I'm not gonna say any other times, but the first thing I'm starting with is putting radicals into perovskites. What does this mean to you? You know what a radical is, right?
I know what a radical is. I know what a perovskite is.
Okay. What do you think a radical does to the NMR?
I don't know what it does to it. And again, I can have a guess on why it would be interesting to put a radical with a perovskite. If I had to guess, it would be lead, right? Is what's in the perovskite.
Lead is usually in perovskite, so you can do them without lead.
I don't know.
Mine
I have no
has
clue
lead,
what it's gonna do with NMR, honestly. I absolutely no clue.
Okay. In EPR.
Yep.
How does EPR work?
EPR is hold on, because I just got a whole bunch of solar smoke in my eyes. In EPR, basically checking how electrons interact with the magnetic field based on their spin, dividing it by energy, seeing when they excite.
Okay. If I say that EPR doesn't work with most molecules, Is that like a revelation to you, or is this something you knew?
It would be a revelation, I suppose, because then what that would mean is, oh damn it! I don't know much about spin. I would need to know. I would need to know how spin works in order to know why.
Okay, well, I mean, EPR is just electrons, and electrons can only have one spin.
Well, no, because
so we're not worrying about nuclei.
I mean, if they go down half and up half, then it would make perfect sense for me to work with all of them. I don't understand why only some of them would work.
Okay, if you have an atom with 2 electrons,
right?
We'll just say an atom has 2 electrons. What is the total spin on the atom?
Oh, on the other, well, they would cancel each other out, wouldn't it? It would be 0.
Yeah. If you have an atom with 4 electrons,
that's
what's
why
the total
that makes
spin?
sense. Okay, no, that makes sense then.
So if you have an even number of electrons,
if you have filled orbitals.
Yeah.
Okay,
yeah.
That makes sense.
Obviously, this is different when you have like transition metals that have electrons that are not paired up, even though you might have an even number of them. But generally, in molecules, they tend to have electrons that are all paired up. So molecules tend to not have an overall spin. And so in EPR, it's called electron paramagnetic resonance because your molecule needs to be paramagnetic.
That makes sense.
Meaning it has an unpaired electron.
Okay, that makes sense.
And why does an unpaired electron interact in EPR? Like why does it work?
Well, it's because it can excite, right? It's because when you apply a magnetic field,
excite when you do what?
When you apply a magnetic field, the possible states diverge, as in you can have either a low energy state or a high energy state depending on spin.
Yep. Okay. So yeah. So our unpaired electron interacts with a magnetic field.
Yes.
Now, what's a radical?
Radical. If I remember correctly, radical was when you took a normal atom. No, I'm thinking of ions. What am I talking about? I think I confused radicals with ions. I don't.
Ion is a charged atom, or a charged. It can be a molecule.
Having an unpaired electron. I know I confused
yes.
with ions. Okay. Shut up. Sorry.
Okay, so if a radical has an unpaired electron,
I see the significance now.
and NMR is using magnetism to look at nuclear spins, which act as magnets. What happens when you put a radical in your sample and you want to do NMR on it?
Would it interfere?
Yes.
Oh, it would.
So it screws with the NMR, is what I'm going to say for now.
So is it that kind of you, well, not accidentally obviously, but like it makes you do both NMR and EPR at the same time?
Yes, actually, that's a very good statement. There's a technique called dynamic nuclear polarization, where you're essentially doing EPR and NMR at the same time, which hopefully I will be doing. But right now it's not what I've been doing. But that's a very, very good question. And the way that works is you basically just do NMR while also doing EPR, and the excitation of both will make things interact and enhance your NMR signal.
Hold on. Yeah. Panzer asked a question, but if the electrons aren't paired, does the spin need to cancel out? Example, can't C carbon-12 have spin between -2 and +2?
Okay, you can have the nature of your question. You can have atoms where the spins don't pair up, but they're generally like transition metals, because transition metals have like a lot of orbitals that the electrons can go into, and they'll fill up these orbitals. They'll fill up different orbitals that are the same energy, before they pair up in the same orbital with each other. So by filling up the different orbitals, you can have higher spins because all your electrons might be spin half or whatever. In carbon, you can't do that because carbon only has a certain number of orbitals, and if you put electrons into it, they have to fill up those orbitals.
You would need to excite only some of the atoms in a very, very comically specific way. Hold on, let me come up with a good analogy for this. Okay, so basically, I have one analogy, but it's fucking awful.
Okay.
So Pandasan, imagine that you're in a room with 6 people. Despite them having 12 hands, you can still expect that they will have the same amount of left hands as right hands, right? No matter what, if you are in a room with 6 people and they have 12 hands, there will be the same amount of left hands as right hands. In transition metals, however, it's kind of like if you were in a room with 20 people but had only 30 hands. So all of a sudden, balance no longer necessary in that scenario. If you think about it, it makes sense, but it's just a really wild analogy.
I kind of get what you're saying, but also like I don't think this.
Hey, if the shoe fits.
I'm not sure the shoe fits on 30 hands.
I mean, a glove. Gross enough. Okay, and then this is where we need to cut.
So today I was just doing NMR on my radical perovskites, which no one's ever made before, by the way. And
I mean that was a really cool thing to say, but you pick such a don't mean to brag tone. I'm just saying, no one's ever done it before.
So, by the way, first person to ever make this.
This is...
and in the NMR, because of a thing called relaxation times, we can see the effect of the radical on the perovskite.
Oh, so is it that you get the initial scan then over time? I still don't know how relaxation times work either.
No, but we'll get to it when we actually.
We're trying to say technically yes, but it's unprovable. It doesn't really work when you have 1% of molecules or more. It's not technically yes, but it's unprovable. It's more like you would need to.
They said unprobable.
What?
They said unprobable.
Yeah. What did I say?
You said unprovable.
Oh, I'm so sorry. I meant unprovable. I meant unprobable.
I was just checking.
It's not really that it's unprobable. It's more like it's. You would need to basically grab an atom and do it yourself. Like, you can have 10 to the 23 molecules or more, but the probability, I feel like, would still beat you on these odds. I randomly soldered the one pin I actually shouldn't have soldered. Because I needed some kind of pin to attach the chip to the board. And so I picked just the random one. And it was the one pin I really shouldn't have soldered. My goodness. Because it's a ground pin, now I need to perform an absolute miracle to nail it. Okay.
The only problem with this this perovskite I've made is that I shone the UV torch at it and it didn't glow. And so I gotta make something else.
One. I've been looking for a perfect flame molecule. Wait, okay, hold on. Radical perovskite. So basically, actually, could you explain to me the significance of? I know significance of perovskites in the NMR, because I don't. As far as I'm aware of perovskites, this is a knowledge check for myself. Crystals based on the metal with the I don't remember the exact. Was it PB or actually X? I suppose X2A. 4B? No, I don't remember. No. How much? What was it?
It's much more straightforward. There's only one number.
PB2A1B or PB2AB?
No.
PBA2B?
No.
What's the number then?
It's usually we'll say ABX3,
X3, okay.
where the B is usually lead.
Ah,
The
here's what I
A
understood.
is
Okay.
some kind of cation, and you know what a cation
Yeah.
is.
Iron with whiskers.
Yeah, you know. Classically, the cation is cesium, but you also have like hybrid perovskites where the cation's an organic molecule. And so part of what I was doing is I was replacing the cation, some of the cation, with a radical which is also positively charged, which is a lot easier said than done. It's quite hard to have a positively charged radical.
Why is that?
Um,
Oh,
just because,
you remove.
I mean,
Actually,
yeah,
no.
because to make something positive, you have to remove an electron, and to make a radical, you usually have to like add an electron somewhere or remove an electron somewhere. But it kind of means that like both ends of it want to react with each other. I mean, you can have a positive sense that it's a radical, but in this case, the positive part is an ammonium group, so NH3 plus, and the negative part is this like NO, and then the O has a single electron on it. So it's a derivative of a molecule called tempo, which is used in EPR as like a signal thing. Like you put tempo in your EPR thing, you stick tempo to something, and it gives you your EPR signal because it's like a relatively stable radical. So yeah, ABX3 and X is a halide. And you know what a halide is?
Yeah, from the periodic table, the ones that always confused me for why they got their own special designation. You are.
I mean, lots of things get their own special, like alkali metals and halides and what's the other one? Noble gases.
Okay,
That's a bit of it.
noble gases make sense. Alkali metals also kind of make sense to me because they're just extremely reactive.
Hmm.
But halides don't have like a straightforward explanation for why they're special.
Halides, every halide is like the same. Like they behave exactly the same, except some are just bigger than others.
Yeah, but that's the pickle because they behave exactly the same. But how would you explain that behavior? That's the part. I mean, I get that
They just grab electrons. They just grab one electron from somewhere.
Okay,
Fluorine
that's
just grabs
actually
it the
simple.
most because fluorine's the smallest.
Okay, that's actually pretty simple way to put it.
I mean, unless you're doing like a master's project where you're making polyhalides, but we won't worry about that.
Hypothetically.
Yeah. Could you imagine making like bromine with 5 fluorines on it? You need like a plasma or something.
Okay, so positive perovskite, positive radical with a perovskite. Anything special
Yes.
about the NMR results of that? The problem here is that, once again, I know nothing about NMR. So I imagine there are a lot of interesting things. It's just that I don't have a reference point for why they
we do NMR. The only thing is, so there's all the relaxation stuff, which I'll explain at some point. The relaxation stuff is the easiest way for us to see that the radical is in the thing, because we just see the relaxation changes, and it's like, oh, the radical's in here. And this relaxation, usually it varies. Well, okay, it can vary from like microseconds to like hours for a nucleus to relax. And generally, everything I've been doing for the last month, to put it into context, has ranged from like 100 milliseconds to like 20 seconds, and that's kind of been the range I've been working
20
in.
seconds?
Yeah. And this, with the radical in, today I was doing some NMR, and the lowest T1, the lowest relaxation time I got, sorry, I can't use terminology yet, was 200 microseconds.
Oh my goodness. Way shorter.
Which is very small. Yeah. So it's very fast, and that messes with the spectra. You can do like what you call relaxation filtering, where you set Yeah, I'm getting too. I don't know. I'm getting too specific.
10 minutes.
I'll get into this. I'll get into this. Yeah, I mean, the spectra are basically just normal, except this relaxation stuff. And then there's this whole dynamic nuclear polarization thing, which is the EPR combined with NMR thing, where I think it just makes your signal better. And for that, there's another uni in the UK who they have instruments that do this mix of EPR and NMR. And they've told us that like if we just send samples, they'll check if it works with our samples, and then we can just go over there and just use their machines.
Yeah, that's cool. Pretty neat.
Yeah. It's very exciting. On Friday, I thought it didn't work because the relaxation time didn't change on one of the samples. But then today we were looking, and it's like there's a big drop, which is very good.
I'll ask a follow-up question, but I can't ask any. I'm waiting for all matter. No, because I don't know anything about it. It's not and I know that even if I ask a good question, you won't answer because we're waiting on the stream. As all matter, I'll need to see how long it'll take them.
So the thing is, right now, it still feels like I'm doing two separate things. Like the NMR feels very separate to the perovskite stuff. Even though I do NMR on the perovskites, it's like there's no clear connection between like electronic structure and the NMR stuff. And I really want to like get there. I really want to be doing that because my whole like research background is electronic structure. So it'd be really cool to be doing, photoluminescent spectroscopy, right?
I can guess from the name.
Yeah, you shine light and you see what light it emits. That's it.
Yeah, photoluminescent spectroscopy makes sense.
Yeah, so it's basically what I do with the UV torch, except you measure it instead of use your eyes.
Competitive looking at fluorescent stuff.
Yeah. I mean, that's all spectroscopy is competitive looking. I would really like to be doing that and correlating it with NMR and seeing like how structural stuff affects the luminescence. I just want to do something luminescent. And there is potential with this radical stuff to get some kind of like... Have you heard of magnetoluminescence?
No, things glow when exposed to magnetic fields.
Yeah, I mean, I don't know much about it, but I think it's like the field around the material will affect the luminescence properties. So like the band gap.
I suppose that makes sense. I mean, okay, theory-wise, on zone, it does certainly make sense. That it could happen and why it would happen.
Yeah, and this would be spintronics. You've heard about spintronics and laughed before.
This sounds awful. Absolutely terrible. I've been thinking myself on getting more back into, well, not really back, only getting into synthesis because I really don't have much synthesis knowledge. I really need to catch up.
Just buy a ball mill. It's really as simple as you just take some stuff and you shove it in, and you press the button, and it comes out. It's literally just like a powder in a capsule, and you just scrape it out of the thing. That's it. You've just got your powder.
I don't think I have the spine necessary to be a mechanochemist. That takes balls.
Okay, I'm gonna go.
No, but hold on, because I can't mess up actually these pins. Okay, this should go right here. There we go. So you just spending all the days in the lab just scanning things, and you think that all of them are the same. They don't offer any unique challenges. All of them are just the same kind of scan.
No, there's a bunch of different kinds of scans.
No.
We use they're called like pulse programs, where you set like the the power and the time for different pulses, and you do like the timing between them. And this does stuff like you know that Wikipedia page with the Han echo, where it had the arrows like aligning and stuff, and
Oh,
rotating around.
oh yeah, right, yeah.
Do you remember that GIF? That's what these different pulse programs do. So you're just deciding where the arrows go and
That is
measuring
not
stuff.
as good of an explanation as you think it is.
Okay. Okay. When you do different pulses of different lengths, we'll move the arrows by different amounts in different directions, and when you're not moving them, they will still move in the opposite direction. So the timing of the pulses is still very important.
Shows you a 4-dimensional cube. Yeah, so basically, this is what the software does.
Yeah.
I don't understand these arrows at all, not gonna lie.
Well, it's because you haven't seen them.
Well, the arrows? Are we talking about the same
Yeah.
arrows? Because I'm pretty certain that...
I don't know.
Hold on, because we might not be talking about the same... The ones I think of, to me, look like... Basically, you showing me a GIF of a rotating 4-dimensional cube and basically saying, yeah, it's pretty simple, it's just that.
Yeah, go to Wikipedia and search
Echo.
spin echo on Wikipedia, and it's these arrows.
Okay, hold on. Just to be absolutely certain. Switch to... This GIF, right?
1 sec. Yes.
Okay, I don't mean to be that guy, but to me it genuinely looks like as if you've shown me this GIF and be like, yeah, that's basically how it works. To me, those two mean the same thing. I mean, look at it.
Okay, the 90 degrees and the 180 degrees is different pulse lengths of radio frequency, and that's all I'm gonna say. And then the echo, don't worry about the echo. Don't worry. Don't worry about the echo.
Oh, but the
Just
material
don't
isn't
worry.
stretching. That's at least good. I remember it stretching somewhere. Where was this? Oh, it was right here, right? It was.
Oh, this. Yeah.
Yeah, there we go. That's the one I remember. That's not that. Oh. Well,
I think I should go before I spill too much.
That's fine. I will tell you about what I'm doing, but to be completely honest, what I'm doing is unbelievably boring.
What are you doing?
I mean, look at this. I am...
Wow, soldering.
Yeah, I know. Crazy, isn't it?
What are you making?
Basically, I have this screen right here. And I have this card reader that I've used to hack cards. That was last week, though. Yeah, last week I was hacking cards. Now I'm making a screen for colon 3. Life's crazy.
Okay.
But both of them use a connection called SPI. You can think of it like USB, basically. Same idea, just moving data around. The problem is that on the device I'm using, the Raspberry, it has only one SPI connection. So... But SPI is clever, so it has chip select. Now I'm going to be throwing around some terminology. You have SPI...
Oh yes, chip select, of course.
Yeah. Chip select actually is convenient because it's exactly what it sounds like. It's a pin used to select the chip. So if you have a device like this, and you pump in all the data, then if the chip select
in a British restaurant. Sorry.
If the chip select is low, then device will accept the data. If it's high, it won't. And the reason why it's important is because what I'm doing effectively right here is I'm connecting all of them together. So I'm going to be sending the same data to all of them. But depending on which device I enable the chip, only that device will read the data. And that's what I'm doing.
Okay.
Yeah. It's awful to explain. I hate computer science and engineering because people who... Well, in my personal opinion, I feel like people who name everything... I just have this really fragile egos in engineering and computer science, which is why it's so difficult to explain. Because the entire thing is simple and so on. My goodness, I mean, look at my setup, right? I'm doing it with a soldering iron, a cheap pair of tweezers, and an ungodly amount of alcohol. It's clearly not difficult. It's not rocket science. Oh, there we go. Still.
Oh yeah, what did you think of the Balatro video, the gameplay?
Where it just stopped to I didn't even know that was a thing that could happen.
She was using mods, but she was just going, and I was like, oh, you should stack these things together. It would like it has synergy, and then
Clearly it did.
yeah, I think it was a bit too much synergy.
When a game tells you that it needs a second, just it needs a
Oh,
break.
it didn't recover. It was like that infinitely, and she had to restart.
Just give it a couple of days, you know. Calculate your points in Palatro.
It's quicker than the NMR.
Okay. Time for the big test. Let me see. That's good. That's really good. That's really good. That's really good. That's really good.
Is this just testing that they're connected on both
Yep.
ends?
The problem here is it's unbelievably annoying. I feel good, by the way, because you know how I always complained I'm a journalist, I know a little bit about everything but nothing at anything? You get what I mean. I'm
Yeah.
never the right guy to ask. With this, I genuinely feel confident and comfortable. I am genuinely good at this. And the annoying bit here is that I've just made all of the connections. The thing is, when you are making things, there are so many. I mean, it's so many points of failure. Because right now, what I'm effectively going to do is there's only one set of wires left from the multiplexer to the chip select and reset pins. One set of wires I need to solder. And then once that's done, all I'm effectively going to do is I'm going to take this, I'm going to plug it into Raspberry, and I'm just going to plug in the device. I'm going to test it. If it works, that's great. If it doesn't, however, that means either one of these wires is incorrectly connected, either the chip is fried. It could also mean that my entire schematic I've designed for the chip is incorrect. It could mean that the software on the Raspberry is incorrect. And like most of these things, in order to test them, I need to test them destructively. So for example, in order to see if the chip is fried, I would need to desolder it and I would need to replace it with another one.
I see.
It's awful. So far, I have been on a streak. Are you familiar with Jamie Page? Music.
With Jamie Page, did you say?
Yeah.
Yeah.
Bird brains and such.
God, you mean Katsi?
Yes, that one. Their music is magical because when I play it, everything I build works. I cannot explain it.
Okay.
I cannot explain it. Yesterday, so okay, when it comes to this chip, hold on. Let me actually do. Oh, you know, let's do it properly because I can. Also, out of curiosity, I'm gonna ask you because I've never asked anyone. Even
play Weather Girl.
Okay.
Do you know Weather Girl?
Weather Girl, I think so.
It's by the trio, which includes Jamie Page, the Flavor Foley.
Oh, okay. I'm familiar with Flavor for it as well. It's okay.
Speak.
When I show you a camera on Discord, do you see the image flipped?
You mean the screen share, or what do you mean?
No, the camera, because right now I have a camera enabled. Is the image flipped?
Do you?
Because
Wait.
yeah, on Discord.
I don't see camera.
Because for me it's.
I see the screen share.
Oh yeah, no, that's my camera.
Oh, okay.
Is it?
Oh, in the snipping tool it's flipped, but in the rest of the screen it's not.
Yeah, that's because
the snipping tool is the rest of the screen is not flipped.
Yeah, because from my perspective, for some reason, Discord is showing me it's flipped. I don't know why.
Discord flips the camera because it's usually a camera on your face, and so
mirror.
It wants you to see the mirrored image.
Oh,
yeah.
that's dumb. That's dumb because that's not what other people see. Doesn't matter. The reason why I ask because if it was flipped, then everything I would show you would make no sense. But basically, I think. Oh, where is the date sheet? No, that's Teflon. Hold on. Oh, because that's Teflon, and I don't want to show the actual article I was looking at. All right. Basically, this is the date sheet for the chip. And it's hilarious because like it shows you everything. It shows you the pinouts. It shows you all the recommended operating conditions. You know what it doesn't show you?
What?
It doesn't show you how to use the chip. All
Oh,
it does is on the very beginning, it tells you that it's a serial in parallel out shift register that feeds an 8-bit D-type storage register, and that's it.
of course, yes.
This description is the entire operating, which is one thing on its own. But what I would like to point out is that this is effectively all I have for figuring out how it works. Whilst they do later on spend an entire page just talking about the package materials information, how to wire the spool, dimension of the spool, the box that the spool will come into, the tube length for each turn. Yeah, right here you have this in blue. Right here you have a bit of green, right here you have in red, all the different colors of the rainbow, pitch black. These are all the same chip, I would like to remind you. It just keeps going. It keeps going and going. Right here you have a whole page just for the image, because why not? So all of that, and this is the only description of how it works. And it's not a lot to go off of, but basically, I'll show you this because yesterday I was listening to Jimmy Page. I wanted to test the theory that whatever I make of Jimmy Page always works, and I just vibed through this entire thing. I coded blindly. I just guessed. I guessed. I guessed how this chip would work, and I just scripted it. And I kid you not, it worked on the first try. Jamie Page's music is witchcraft. I don't know what the mechanics
Vibe electronics.
Vibe electronics. I hate that vibe coding refers to coding with AI, because I think a much better technique for vibe coding would be just coding with vibes alone, which is what I do. Oh, now I need to do all the other things. I don't mean to keep you here, by the way, because I realize how unbelievably boring what I do is in this case.
Nah, it's interesting.
It is interesting if properly explained, but unfortunately, as I mentioned, engineers have very fragile egos and they need to make absolutely everything as complicated as possible. Alright, this is the ground side, which means this is the side on which we have 7 connectors. The right 4, we're gonna go for the reset, the left 3 plus 1 on the other side will be the pins, which means I have only 8 connections left, and then I'm gonna need to cross my fingers, hope I didn't mess up anything, because if I did, I'm going to have just a lovely time. This, okay. There we go. Actually, what kind of music do you listen to, other than Azali?
I listen to quite a range of music. My favorite artist is Eden. Do you know Eden?
Maybe. Do they make... Oh no, it's not EDM, is it?
He used to do EDM many years ago, like 10 years ago.
Is it possible that that's where I know them from?
He was called the Eden Project back then.
Oh yeah, that
You
genuinely
do
might be
know
it.
Eden Project.
That genuinely might be it. I don't know why, but Eden Project genuinely sounds familiar.
Let's see. He released like 5 new songs today. I'm gonna go to.
Oh my goodness.
Which is the most famous Eden Project song? So you know I like sing and stuff. I used to perform some of this guy's songs. I like learned them on the piano, and I would sing and play the piano.
Damn, I love singing and I can play the piano, but singing and playing always just messes with me. It's really difficult.
It's very weird because it's like I would learn the two separately, and then as you try and put them together, it just doesn't work.
Yeah,
And you just
overwhelming.
keep going, and there's like a certain point where it suddenly just fits together, and like the rhythm just all like it just works. It's very weird.
So
I'm looking for these songs. I mean, his most famous one is probably this. I find it very generic, this one, but it is his most famous.
That's usually how it works with most famous songs.
Yeah, this is like his most generic song.
See.
This one is one of my favorites. This one. And my favorite to perform was this one.
Wake up, let me see. Let me see.
thoughts?
It's really good. I it's it's really good.
That's
Wow.
it.
Yeah, I mean, give me a second. It's a lot. I am. I don't deal well with these kind of songs.
Is it too much emotion?
It is. It is way too much for me.
Damn.
Oh, it's a really good song.
I like a lot of his music. The second one I sent you is quite good as well. It's a bit more electronic.
Wait, the second one because I was just listening to Wake Up.
Yeah, drugs.
Oh, okay.
You know in the Spotify rewind thing every year.
Yep.
One year it was like it popped up with the favorite song thing, and it was like you couldn't get enough of drugs. I just burst out laughing. Thoughts?
It's also really good. Um, I'm gonna add these to my playlist as well.
His I would say like his music changes a lot between the different albums. Like the older ones are more poppy and electronic, and then was it Vertigo is my favorite album. Like they're all just get you in the feels, and then the more recent ones are kind of like they're kind of poppy again, but in a different way, like in a more experimental pop. Less feely, but more. I don't know. It's like, I don't know. They're interesting. I met him a couple months ago, actually.
Really? Oh.
Yeah, he was doing like an album reveal in London, and he posted it on his Instagram. He was like, "Oh yeah, tonight we're doing this," and so I was like, I just went because it was in London, and
Oh,
I got to say hi.
that's great.
So it was like I don't know, 30 people there.
Oh, that's surprisingly few.
Okay, no, more than 30. It's like 50. I don't know. He hung around for a bit, so people just chatted.
Great.
Okay, I'm gonna go
That's
because
fine. I'm also gonna end the stream soon.
okay. Have fun with your beep boops.
Alright, I will have my fun with my thingamajigs. See ya.
And let me know when we should do some NMR.
Alright, I'll let you know.
Okay. Alright, see you.
See ya, bye. Well, everyone, I think that will be it for today's live stream. Indeed. Yeah, it's a shame that I didn't get this to work for stream, but I'll finish it. Stream, I'll post an update on how it works, if it works. Otherwise, are just really fighting me and don't want to stick, unfortunately. I'll make them. Yeah, I suppose for now that'll be it. Thank you everyone so much for watching, and have a great day.